I currently build two extremely sturdy, small form factor CNC routers suitable for milling steel. In this video I will show how I machined the parts, and in the next one I will show the assembly. And if you want to know how and why to fill extrusions to make your own CNC build a tank as well, watch till the end. Hello and welcome to my channel. In my last video I introduced the project and explained the design and specifications in detail. And I do have to apologize for the long time until this video came out. But I had some unexpected delay in the transport of the heavy base plates from my home shop, where I mill all the parts, to my new shop, where I assemble the machines. It took the forwarder a staggering 3 weeks instead of 1 day, believe it or not. On a positive note, since my last video I received another order for a smaller mill with less features and simpler CNC controller, so I decided to build two machines in parallel. In this video I'll focus on the machining of two important parts, also to show you my workflow with the heavy base plate. Here you can already see me struggling with the 100 kilo heavy raw material. I use a pre-faced 70mm thick plate out of 5083 aluminium. This is a casted material which has, in contrast to rolled material, very little residual internal stress, and it remains as flat as it is even when you remove material. The work holding is done by vacuum, and I first have to prepare the vacuum plate by opening the various suction fields. Then I add a vacuum card and push the plate in place. I work in a confined space, and unfortunately I cannot use any cranes or shoplifts. So the only way to handle such a heavy part is by pushing it around. Once the plate is on the vacuum table, I align it parallel to the axis using some stop blocks. This one is in fact 200mm deeper than my vac table, so there is a 100mm overhang in front and back. But at this thickness it doesn't matter and do not cause any chatter in the free floating areas. Then I set the workpiece 0 and start with the underside of the plate. The workflow is to mill the first half depth of the outer contour with a 1/4mm stock to leave. I use a roughing end mill for this because it makes nice little chips which are easy to manage. If I were to mill the full depth contour using the finishing end mill right away, the volume of chips would be so large that I'd run into problems with it on my machine. You'll be able to see that later on. I added as well a finishing pass, so I have a clean surface for the workpiece probing and the second op. After the bottom side being done, I had to flip the plate for the top side machining. As I said, the thing is rather heavy with 100 kilo and there's no shoplift available. So I had to use the good old technologia, also known as gravity. For the probing of the second op, I used the sides I already milled with the finishing end mill and the gauge block to bridge the gap. Then I removed again the remaining material with the roughing bit before I finished the outer contour with the 5-loop finishing end. Here you can see the volume those thin long chips create, and as I mentioned earlier, if I had done that from the beginning, it would have created a big issue, since on a desktop machine the chips remain close to the milling area. This is normally no problem at all because there is plenty of space, but these chips are an exception. I removed the chips during the milling from time to time and added a few additional spring passes to compensate for the deflection of such a long end mill. After the outer contour was done, I gave the mill a brief cleaning before I finished the rest of the base plate. The benefit of this design is that all the relevant features, like the mounting surfaces for the rails and bearing housings, alignment edges, etc., are all done in one operation and are perfectly aligned to each other. And this is how the finished base plate looks like on the machine. Another part I would like to show you is the Y-axis board screw nut housing. I always make my own nut housings because I prefer them over the ones that are commercially available, mainly because I add 2 more threads and generally increase the thread size anyway for an improved connection to the axis. But this one here has in addition an odd W shape. This is required to mount the cover directly above the board screw, which otherwise would be exposed to chips. Another key design element are the extruded profiles for the gantry. I went with this design in combination with the one-piece machined base plate because this combo is easily scalable. The machine is available in 50mm increments from 300 by 250 to 500 by 400mm. And although UHPC and epoxy granite have better dampening properties than aluminum, this lineup would require 9 different molds. But there is a good way to dramatically improve the dampening properties of the profiles by filling them with epoxy granite, or in my case, an epoxy sand mix. I use an industrially dried sand with 0.5 to 1mm grain size with roughly 15% epoxy. I link both in the description below. I also added some black dye to the epoxy so I can see whether everything is mixed well. 3D printed some covers and funnels for the filling, and quite importantly some inserts so that later on I don't have to drill through the epoxy and sand mix. The filling is rather straightforward. All you need to do is to compact the stuff from time to time. Shaking of the profiles would make absolutely no sense here at all, because the mix is rather dry and would not bleed or compact when shaken. I always leave a gap of roughly 5mm, which I later fill with epoxy. The reason why I do this is that I absolutely want to avoid that some loose grains can get in between the base plate and the gantry during the assembly, which might throw off my alignment. After the epoxy end pour is cured on the first side, I flip the profiles around, remove the end caps and seal the mix on the other side. This pour has to be repeated 2-3 times because the mix still absorbs some of the epoxy, but it gives me a very good seal at the ends, which is important for the later machining. I always machine the ends to make sure that I have the exact same length of the profiles left and right. I just don't want to rely on the manufacturer's saw cuts because their tolerances are just too high for a precise machine. I use a few spring passes here again to compensate for the deflection. I have dialed in this process over time and measured the parts quite often, so that I'm confident that the difference between the top and bottom over the 80mm thickness is within a few microns. Looks like the runout of the end mill tip and the deflection compensate each other rather well. Then I drill the holes for the profile connection, and for this process it was so important to have a 3D printed spacer in the profiles, otherwise this would kill the drill immediately. Finally, after a thorough cleaning, the profile is flipped around for the final operation. I always machine the 0.5mm deep pocket into the vertical profiles where the horizontal gantry beam is attached, because the profile sides are slightly wavy by design and I prefer to have two perfectly flat surfaces on that connection. All in all, this is a rather complex process just for a few profiles, but the gantry is one of the most important elements when it comes to machine stiffness, vibration absorption, and the quality of the milling surface. I added in total 10 kilo weight to those three profiles, which are already heavy-duty profiles in the size 160 by 80 on the big machine and 120 by 80 on the small one. But the biggest difference is the improvement in the dampening properties, and you can hear this quite well. And that's it for the first part. In the next video I will show the assembly of the machine with a focus on alignment, which is the most important element when you want to build a precise CNC machine by yourself. But before that, I will show you how I built a super sturdy workbench out of extruded profiles in less than a day, because let's face it, my current build table operates way beyond its limits. If you don't want to miss that, subscribe to the channel and hit the notification bell. Also, please give this video a thumbs up if you liked it. Stay tuned and see you next.